Stop treating your Kubernetes like a magic. Many teams spins up the cluster, never set the request limit, leave CI runners running for 24/7, and wonder why their bill has exploded. Setting it up once and never looking back. That's not Kubernetes failure, that's your laziness. In next 7 minutes, I'll explain you 5 concrete ideas that will help you to reduce the bill for next month. Here's the plan. First, see where the money goes. Then shrink what's wasteful. Then set auto scalers so you don't pay for the idle capacity. Add spot or preemptible node pools for batch-wide workloads. And finally, clean up CI and cron jobs. That's the cost culprit. I'll leave the commands and the checklist down below in the description so that you can also try it out. So let's start the video. You can't reduce what is not visible. So the first thing you will get is the cost per namespace, pods, and deployment. There are multiple ways to find it out. The first method is using KubeCost. KubeCost directly maps spend to namespace, labels, and pods. Point it at your cluster and it shows who is spending what. If you already have a cost dashboard, great. If not, KubeCost is the fastest way. If you don't have a KubeCost, fine, you can also do that using your kubectl command. You can simply get kubectl top nodes and the cost from those nodes. You can also find out the pods with no resource request limits using kubectl command. The JSON path commands list pods and whether they have resources request. The third way is using Prometheus. Using PromQL, you can also find the wasteful pods or the CPUs. The utilization query gives you a percentage of requested CPU actually used. If a pod requests 500 M CPU and uses only 50 M, utilization is 10%. That screams Rightsizing. What to look for? Namespace that has high request but low usage. That's a low-hanging fruit. Simply sort out those namespace that are requesting more than the usage. So after doing that, the next step is to right size those pods and namespace. Let's do it. Request and limits tell Kubernetes how much to reserve. Right sizing is the art of asking just enough. There are 3 practical right sizing approaches. The first one is using the manual conservative method for the stable services. If a pod was at 500 M request and average usage was 120 M, drop request to 200 M first, watch for out of memory or throttling, then iterate. Next one is using vertical pod scaler in a recommendation mode. Vertical pod scaler is an add-on component that automatically adjusts the CPU and memory resources for pods based on their actual usage. It can recommend you a new size, but it's on you to implement that or not. Also create the VPA with update mode off, wait for the recommendations, and then apply conservative changes manually. Or third method is to use the tools like Goldilocks or KubeCost recommendations to automate suggestion. There are some risks when you don't right size properly. The first one is out of memory and second is throttling. You can mitigate those using canary changes. That means one pod at a time. Second, shorter rolling update strategy. That is maximum available 1. And the third one is to monitor those alerts, OEM issues and the throttling issues. Autoscaling is a backbone of cost control, but misconfigured autoscaling cause noisy scaling and over-provisioning. So let's tune them right. The first tool that is used is horizontal pod scalers. For your information, there is a slight difference between horizontal pod scaling and the vertical pod scaling. Horizontal pod scaling is to scale the number of pods based on the request, and vertical pod scaling is to scale the capacity of memory or the CPU usage based on the demand, of course. So for the auto scaling, HPA, horizontal pod auto scaler, is the required one. So for this one, we need to set sensible min and max and a target percent that matches the real usage. The second tool we can use is cluster autoscaler. It removes the empty nodes. But if you reserve too much buffer, like having many pods with high request, cluster autoscaler can't remove nodes. So the trick is to use a small buffer, but use pod disruption budget PDB sensibly. And also don't rely on CPU, use custom metrics or request-based ratios for stable scaling. And the third tool you can use for auto scaling is Carpenter. It provisions nodes faster and handles mixed capacity types well. But the main idea is to match your autoscaler to your workload pattern. Let's first understand what is spot and preemptible instances. They are the spare cloud instances provided by cloud providers. Kubernetes uses these as a worker nodes for fault-tolerant, interruptible workloads like batch processing, CI/CD, or batch rendering, saving significant costs. Think of spot instance like a bazaar where you buy the cheap stuff but not your wedding suit. So simply create a node pool for spot nodes and label it example spot equals to true. Then schedule tolerant pods to that pool. Labeling nodes with spot equals to true and adding the node selector plus toleration to pods, it can handle the eviction. For stateful workloads, prefer cheaper reserved instances or mix spot with on demand. The trade-off is spot is cheap and intermittent. Don't rely on your big services or critical services on spots. As I said earlier, CI and the frequent jobs are the main reason of high cost. A runaway job or poorly built cron job can burn your money quietly. So the first step for this is to scan the pipelines for long run jobs, also the frequently running jobs, and also the job that requires huge resources per build. So you can simply reduce the frequency of those jobs if possible. Also, you can use the spot runners for parallelizable jobs, and you can also add a cache if possible. And the most important one, add alerts when the build time or the runtime exceeds the thresholds. So we can create the checklist to reduce the cost from a Kubernetes. The first one is cost visibility using keep cost or export from QL. Second one is run utilization queries. Flag the pods that has less than 30% utilization of the total resources. Third one, right size conservatively. Fourth one, tune your horizontal pod autoscaler and cluster autoscaler. Fifth one, move your batch or CI to spot node pools with labels and 10s. 6. Enforce resource quotas for CI and cron jobs. And the 7th one, monitor, measure, and iterate. That's all for the video. I hope you liked the content, and I also expect you to implement this in your cluster. I'm Subhas, and I promise you to see you in the next video. Thank you, and bye-bye.